Good day, beautiful people. Hope you all are doing good. On today's lesson, I will be showing you all, teaching you all how to solve for the number of the sequence. So now, in this question, it's a sigma notation question. So now, we are given two sigma notations, right? So we are given an instruction to determine the value of P. So now let's check first what is happening here. So remember what does sigma mean? And yet sigma, it's this type of thing. What does this mean? Sigma means the sum of the terms, né? So which means basically now here we are given that we should find the sum of the terms in the sequence, and we are also given a general formula of the sequence. So now how are we going to find the sum of these two patterns, né? Now this first one, remember, it's an infinite pattern. Why do I say it's an infinite pattern? Because the last number of the term, it just is infinity, which shows the pattern continues. It doesn't have any ending, né? So now hence why this basically shows us that it's an infinite geometric pattern. So now remember, now basically here what we are doing is that we are given that the sum of an infinite geometric pattern and the sum added to the sum of an arithmetic pattern, which we are given the first number, that n is equals to 1, which means for us to find the first term of the sequence, we have to substitute with 1. And yet we are not given, unfortunately, we are not given for how many terms are there in the sequence. And yet we're not given the number of terms in the sequence, and then we are given the general formula. Né? Then basically here it's the sum of the infinite pattern plus the sum of the arithmetic pattern. When we add together the sums, they are both equal to 484. So now, first things first, né? What must we do? We need to firstly check this one and deal with it and find the sum of these terms, really, because of why. Basically now, for us to find this sum of arithmetic sequence, we need to find this one first, because this one is easy because of it's an arithmetic sequence. We know we can find it's a geometric sequence, this one, sorry. So it's easy for us to find the sum of these terms in the sequence. Whereas when it comes to the other one, it will be hard for us because we do not have the value of P, which is the value of the last number in the sequence, which is, it shows us basically how many terms are there in the sequence. So it will be hard for us to find the sum of the terms without knowing how many terms are there in the sequence. So in this exercise here, we will be solving for P to find how many numbers are there in the sequence, né? So now firstly, we find first term number 1, term number 2, and term number 3. Remember that here, it's basically the general formula of this pattern. So we just use the general formula, n is equals to 1, which means the first term, for us to find the first term, we substitute with 1. So substitute with 1 to get the first term. It gives us half. Second term, it goes from 1, then 2, then 3, then 4, like that. Né? So then 2, it gives us a quarter, and third term, it gives us 1/8. Né? So now we found the first 3. One may ask, why must we find the first 3 terms in a sequence? Remember that the formula of the sum of infinite terms, it's something like this, and yet it's a over 1 minus r, which is, we need a, which is the first term in the sequence, we need r, which is the ratio. And remember, the formula of finding a ratio is equals to T3 over T2 is equals to T2 over T1. Hence why we need the first three terms to find this ratio here. Okay? So then after that, we just substitute what we got. So A, it's half minus 1 minus R. R, it's half. Ne? We found it here. Saying T2 over T1, it gives us half. And even if we can take T3, which is 1/8, over T3, 1/8, divide by 1/4, it still gives us a half. Ne? It shows that the ratio, constant ratio, is half. Then when we punch everything here in the calculator, it just gives us 1. Ne? Gives us what? Gives us 1. So now we know that basically it's 1 plus the sum of the arithmetic, let me just say as A, it's equals to 484. So for us to find the number of this one, it's like we are doing solve for x. We take that to the other side and it subtracts, it becomes 483, which will be the value of the sum of this arithmetic sequence here. Ne? So now let's go this side. So now this is just basically just that simplified. Ne? So now we know that although all this is equal to 484, but we know that this is equals to 1, this is equal to 483. When we add both of this together, they give us 484. So now it's easy now for us to find the value of P. So remember now, what is the value of P? Again, the value of P is the value that shows you the last term in the sequence. So basically it shows you, okay, so if probably we are in this term, the number starts from n, which is 1, and maybe it ends at 23 or 34, it just shows us that the terms in the sequence are 34 terms. If probably we have this number, we will know, oh, from the first one, second one, third one, fourth one, up until this value here, it will be the terms in the sequence, basically. Remember, it just shows you, basically, it helps you to determine how many terms are there in the sequence. So it's basically like more or less like the last term in the sequence. Ne? So now, ne? We continue. So now, using this general formula, we can now find the first term, second term, and third term. Again, another one may ask why first, third, fourth, why don't we try to find the fifth term, sixth term, or seventh term? There's no need for that because of now. Remember, using the first three terms, we can find the difference. So why we need this first three terms? We need our A, which is term number 1, and we need our difference because the general formula of arithmetic sequence is this. And yet it's n over 2, which n is just basically like P, just shows us, oh, how many terms are there in the sequence? 24 maybe, or 34 or 35. A, we needed it's from the first term, and D, we needed it's from the difference. Ne? So now we just substitute. Now where there's P, we can put, where there's N, we can put P. And get why? It's because of, remember now, we are looking for the number of terms in the sequence. So let's say, for example, we know that, let's say, for example, it was, we already know maybe the value of P, probably it's equals to maybe 21. We know that the sum of 21 terms in the sequence are equals to 483. Basically, that's why we need to find the value of p, so that they'll know, okay, this much value, this much terms in the sequence, when we add them together, they'll give us 483. Okay? So from there on, we just substitute. Where there's p, we put n. Where there's p, we put n. Now, the number here, it's the number which is equal to the sum of this arithmetic terms in the sequence. And yet, now here it's just factorizing here. 2 times p minus 2 times 1, and then it gives us 2p minus 2, then 6 here. So now we have p over 2, and we have in the bracket 2p plus 4. So now how do we deal with this? Now we can just simply do factorization, or you can either probably do cross multiply, but I prefer us to do factorizing first before doing cross multiply. Ne? So factorizing, it's p over 2 multiplied by 2p. Remember, it's like half p times 2p, which the half and the 2, they will cancel out, and then we'll be left with p multiplied by p, which is p squared. And here it's p over 2 multiplied by 4, which is just half over 4, which is just 2p. It's equals to that. And then we take this to the other side and we solve for p. We can either use the quadratic sequence, the quadratic part formula. Now I prefer the quadratic formula because of 483 is a huge number, so you would waste time trying to find the factors of 483 and 2. Ne? So now here, after this here, we now find two roots, and yet p is equals to 21 and p is equal to negative 23. So now this is not applicable because of it's a negative term. So remember, p cannot be a negative because of we cannot have negative 23 terms in the sequence. And yet remember, it's highly impossible. So the number will be 81. So basically, this sigma notation is basically like 21 and n equals to 1, 2, n plus 1. Basically, this is something like this. I hope you all enjoyed this video, and don't forget to like, to share the video, to subscribe to the channel. Hope you all enjoy the rest of your day. We'll meet again next time. Bye bye.